Hi friends, this is Selvajan here. Welcome to my networking channel. Hope all are doing good and safe. And today let us discuss how to configure GLBP. So GLBP is a global load balancing protocol which performs load balancing and in which all the routers will be forwarding the traffic by consuming a portion of overall traffic. So each and every router will be forwarding the traffic, right? So I already told about the AVG and AVF role. So here three switches I configure the physical IP 10.2, 10.3 and 10.4. So here I connected router to show the how the GLBP waiting function works, right? So this is the physical IP 10.2, 10.3 and 10.4 all will be using the same VIP IP, that is 10.1, and you have connected 4 clients. So whenever the client sent an ARP request for the virtual IP, so the AVG, that's the primary AVG, will answer the ARP request and it will send a ARP reply. So the ARP reply contains the virtual MAC address sending to the individual clients. So that is the main function of AVG. So when the primary AVG goes down, the standby AVG will take over the active role. So how it is done means both will be sharing the hello messages periodically. In case the standby AVG does not hear any hello messages, so this will go down and standby AVG will take over the active role. The same function with AVF. So AVF also, each and every router will be an AVF. That is main function for forwarding the traffic, right? So when this AVF goes down, automatically the AVG can assign the AVF role to the secondary router or the switch. So this is how the architecture works. So now let us view the configuration, individual configuration. So we can view show GLBP. Before that, let us view the configuration. Show run interface VLAN 10, right? That's a VLAN I configured, and this is a primary physical IP, VIP IP, and this is an priority is 200 because this is a primary AVG which is selected by the highest priority. And preempt is for preempting role, just like HSRP will work. When the primary AVG goes down, standby will take over the active role. When the primary comes up again, automatically it will take over the active role. So that's the function of AVG, right? So the second thing is, let us view the secondary router. Show run interface VLAN 10. So this I configure the priority is 150. This will be the standby AVG. When the primary goes down, AVG goes down, this will take over the active role. The third thing, I have not configured any priority. This will take the default priority, right? So after that, what we can do, let us view the configuration. Show GLBP brief, right? View the configuration, and this will be the active router. This is going to answer the ARP request and it will send the ARP reply containing the virtual MAC address sent to the individual clients, right? So this is an active virtual forwarder. So each and every AVG will be having an active virtual forwarder. So this is active for first MAC, that is one, right? So you can view here, show GLBP. You can see here, right? So this is an active virtual gateway, and this is a hello passages are sent every 3 seconds. And this is a preemption enable, and standby is 10.3. This is standby AVG and the priority value, and the waiting is always default is 100. So this I configure the threshold value. I will show how to do that. And after that, these are the group members. Load balancing is how it is load balanced in a round robin fashion, and these are the forwarders. So there will be always one forwarder will be active. That is forwarder is nothing but AVF, active virtual forwarder. So it is one state is active, the remaining will be in the listening stage, right? So why remaining listening stage? If anything goes down, this will become active. So that is the main purpose. So this is in an active stage. Similarly, go to ESW2, show GLBP brief. So this will be having the standby AVG. This is selected as standby AVG. So this is active for the virtual forwarder 03 MAC, right? Similarly, ESW3, show GLBP. So this will be having the individual forwarder active. This is active for this forwarder too. And this is having the default priority. So this will be in the listening stage. So GLBP, show GLBP brief, right? So this will be in the listening stage. Always one will be in active standby, and this will be in the listening stage, and it will be having one forwarder active, right? This for forwarder MAC is 02. So this is how the GLBP works. So what we can do, I'm going to show the waiting function. So here I configured a router. Here I configured the IPS 1.1 and 1.2. So what happened when I'm shutting down this interface? When I'm shutting down this interface, what happened? Automatically, the waiting will be decreased from 100 to 50, right? So the waiting will be automatically decreased from 100 to 50. Automatically, the AVF role will be assigned to this thing, secondary AVG. So automatically, this AVG assign the AVF role to the secondary switch. So now let us shut down this interface, that is F1 by 1. So let us go to the configuration and shut down the interface. interface fast Ethernet 1 by 1. Let us shut down. So what happened? Immediately you can see the forwarders will move to the listening stage, right? So you can see show GLBP brief. So what happened? This forwarder is showing the active. After some time, it will move to the listening stage, and automatically the remaining forwarder, right, will take over the active role. So that will take some time to release its role. So that role release is done by AVG, right? So I already told. So AVG performs three functions. One is it will answer the ARP request. It will assign the virtual MAC address to the client. And third thing, it will assign the AVF role to the individual router. So in case this AVF goes down, what happen? Automatically this will take over the active role. So I'm shutting down this interface. What will happen? It will decrease its priority. So let us view the configuration. Show run interface VLAN 10. So that's the thing I have configured. GLBP waiting. It is I have to assign the threshold value. This is a threshold value I configured lower 70 and upper 90. And track one decrement 50. So what happened? The waiting attribute value is 100. Default value is 100. So when the interface goes on, automatically it will decrease the interface from value from 100 to 50. So it will change from 100 to 50. So what happened? Automatically the AVG assign the AVF role to this secondary switch. So that is the main function. So let us go to the configuration. Show GLBP brief. See, now you are able to see. Previously you are seeing this as an active. What happened? This active role will be assigned to the secondary AVF. So here you are able to see, right? It will send to listen to active. Show GLBP brief. So this will be for this forwarder will be active for this MAC, that is 3 MAC. And similarly, let us see the ESW3. Show GLBP brief. So this will be active for 1 and 2 MAC. So what happen? Whatever the case, even whenever active virtual forwarder goes down or whenever the interface goes down, what happen? Automatically this will be taking care of forwarding the traffic to the individual client. So that is the main function. Each and every router will be an AVF. In case any AVF goes down, automatically the sending the virtual MAC address will be handled by this AVF, right? So it will automatically forward the traffic sent to the virtual MAC address to the individual client. So that is the main purpose of AVF. So AVG also, whenever the primary AVG goes on, automatically this will take over the active role. Secondary AVG will take over the active role, and it will take part in answering the ARP request for the client, right? So that is the main purpose. And let us see the client traffic, whether we are able to ping the IP. So here ping 192.168.10.8. So this is the second client, 10.9 is the third client. This is the fourth client. So whatever case, even when it goes on, the client traffic will not get disturbed because each and every router will be actively participate in load balancing. So all the router will be forwarding the traffic in case if anything goes down. So here I will shut down this interface. What happen? Automatically the traffic will be forwarded from the ESW2 to all these clients. So this is how the AVG works. So now what we can do, I will go and shut down this AVG interface. So now I am going to activate the interface ESW1. Fast Ethernet 1 by 1. Let us activate this interface. So now what I'm going to do, now I'm going to shut down this AVG. So primary AVG let us shut down, and let us see what happens, whether the secondary AVG is taking the active role. So let us see. Show GLBP brief. So whenever the primary AVG goes down, the standby, that is the secondary AVG, will take over the active role. So now let us shut down the interface. Now let us go to the, oh yeah, it came to the active mode, right? So it again came to the active mode. So now let us go to the configuration mode, interface VLAN 10, and let us shut down this interface. So let us shut down this interface. What happen? Automatically the standby AVG will take over the active role. Show GLBP brief. So we're able to see, right, this will take over the active role, and even the active virtual forwarder will be handled by the secondary AVG. So the secondary AVG will take over the role in assigning the active virtual forwarder. That means it will answer the ARP request and it will forward the ARP reply information, right? It will forward the virtual MAC address to the individual client. Show GLBP brief. So see, it is active for the active virtual forwarder, that is 03 MAC, and similarly the CSW3 will see. Show GLBP brief. So it is active for the forwarder 1 and 2, right? So whatever the case, what happened, even the AVG goes on, automatically this secondary AVG will take over the active role, and it will answer the ERP request for the individual client. So it will send to the virtual MAC address to the individual client. So and even the client traffic will not get disrupted. So let us go to the individual client PC and let us start pinging PC1. So we're able to ping the IP, right? The client IP. One is 8. Similarly, we ping from the client PC4. 192.168.10.7, 10.8, 10.9. So that is the main function of AVG, right? So the two things you need to remember. First is AVG answers the ERP request, and it will assign the virtual MAC address. Then it will send the traffic to the virtual MAC address to the individual client. And the second scenario what I have shown is whenever the AVF goes down. So I have shut down this interface, and what happened, the priority value, the waiting priority value decreased from 100 to 50, and automatically the AVG assigned the AVF role to the secondary router. That is the second scenario. And the third scenario, I have shut down this primary AVG, so the secondary AVGs take over the active role and the client traffic will not get interrupted. So this is how GLBP works. So GLBP main function is load balancing, and all the routers will actively participate in the load balancing by forwarding a portion of overall traffic. So that is the main purpose of GLBP, and there are several load balancing algorithms. So the default algorithm is a round robin fashion, right? I hope you understood. Thanks for watching. Please subscribe me for more videos. Thank you. Have a wonderful day.